Hello everyone. Again, just want to give a shout out to ReproRehab for giving me the courage to do another one of these environmental tutorials in R. Today I'm going to be talking about air quality index collected through the Environmental Protection Agency. So I have a script here, and I'm going to kind of lead you through the complete journey of all of the different ways in which I attempted to get data from the EPA, air quality data from the EPA, and the results were varying at times. And so it was essentially seemed to be very easy at first, but of course only gets harder as you go. So I've already run the script through, so just to save time, and so I don't have to pause and continue to unpause. But basically I have the same data that I used in the previous example, where I have the zip code from participants have entered, as well as the state abbreviation that they provided as well. The first thing to know is that the EPA actually have its own R library called PWFSL smoke. Don't quite know what all that stands for, but essentially you can download this, install this package, and load the library, and you can actually use the function EPA download data, where you set the year, the parameter code, the download directory where you want the data to actually be downloaded onto your computer, and then the base URL, exactly where you're going to get this data from the EPA. And so you can always go to the help documentation and kind of guide you through this. I had done this to download the zip file right to your computer, so it seemed like a lot of the hard work was already going to be done compared to previous tutorials where I had to download everything by clicking my way through a website. I thought at first that this was all going to be pretty easy. However, there are things that are basically incomplete for the most part. So here I'll show you this one of the data sets that I had downloaded for the data of 2021. It was an hourly looking at all of the data from that I thought was going to be across the US. And we can see here I named it EPA 25, and so I had over 2.3, almost 2.4 million observations across 24 variables. And we can look at exactly what those variables are here. And we get, a lot of the things that we think we would like to get: state code, county code, site number, parameter code, the latitude and longitude of where exactly the site is within the United States, and then the sample measurement, the time that it's measured, and then the what is it called, the unit of measurement that the sample is done in, as well as the state name and the county name that the site exists within the United States. So I thought, okay, this will be very easy, although as you notice there is no zip code data in here, and of course this is going to be something that's somewhat of a limitation I have found when trying to go from zip code to other types of government accessible data for environmental factors in particular, because zip code is really only used by the Postal Service, and a lot of the other government agencies don't really going to use zip code as a way that they're going to organize how they collect data. And so this is going to be something that we have to work around in order to kind of figure out the best way how to link the zip code, basically the location data that our participants provide us, to that of what would be considered a reasonable air quality measure for that individual based solely upon their zip code. And so I thought this would be easy. I then did a quick sanity check, and I just looked at the table of the state name within this data that I just downloaded using this API, and I found that I only get 23 out of possible 50 states. I do get Puerto Rico, however, but I'm obviously missing about half of the states here. So why that is, I am not sure. But it essentially I came down to the conclusion that I'm just going to have to download these things myself, and that is what I did. And so when I go to the following website here, which I have included within the script, I essentially downloaded for the year of 2021 every state, including the Virgin Islands, Puerto Rico, and Washington, D.C. And got separate files for each of them, including all of the sites, specifically for the pollutant PM 2.5, which is shown to be kind of a major pollutant that is linked to asthma and heart disease. So that would be one that would be interesting to kind of look at for the purposes of rehabilitation science. And so I've already downloaded all of these within a separate folder here. Here we go. As you can see, 53 entries. I'm basically going to do something similar to what I had done previously with the area deprivation index data from the University of Wisconsin. And so, but I had to do all this by hand. So I'm actually going to post these data, which was basically, I'm going to try and save you something like 50 to 60 clicks, so you don't have to do all this yourself. But if you wanted to for a separate year or a separate measurement, you can do that. You will have the site to be able to go to and download these data, download different types of data yourself. But I'm going to upload these data to a GitHub repository, some type of repository for easy access to. And so I'm going to set my I have this, as we kind of work through this script. Basically, this was a dead end for me in terms of being able to get air quality data across the entire country. I'm going to go ahead and I set my directory to the to where I have all of my air quality data that I downloaded by hand. And I have my file names here. As you can see, kind of same deal as before. I'm just basically going to read in each of these files individually within a loop and then create kind of a whole parent folder that's going to give me the average air quality index and PM2.5 for every county within each state of the country. But I'm going to do a quick sanity check first. So I'm just going to take a random file from my list here that I downloaded, and I'm going to go to visualize it over time. And what I can see here, quite interestingly, is that this is the state of Michigan. Yes, the state of Michigan. And you can see that some counties, at least when we look at this by county, have more measurements than others. And this is because some counties, ones typically with larger populations, have more sites than others. So they're going to be getting double the measurement in some cases compared to other counties that are smaller and may only have one site. As you can see here, there's actually quite a bit of missing data across the entire year for this particular county, Manistee. And so that is something to kind of take into consideration as you kind of figure out how you best want to summarize the data across these different counties or perhaps these different sites. If we were to look at this data as histograms, I don't know why it's like that, but nevertheless, we can see that they're pretty normally distributed, although some of them look pretty uniform, maybe some of them are a little bit skewed, so you have to kind of figure out if really taking the mean versus the median of these types of data across this year time frame or however long of a time frame you look at is really the best thing for you. Oh, I know, it's because I did that. Let's look at this again. There we go, that's much better. Okay, so now we have the scales free and everything. It looks a lot better. But some of them are definitely a little bit more skewed. Here's the one that had a lot of missing data, so very few counts overall. And here we can see on the y-axis the daily AQI. Anything over 100 is considered, I think, sensitive, is a threshold that's high for sensitive groups. Okay, so in this loop here, I'm basically going to go into each file, store it into a temporary variable. I'm going to use that to then get the aggregate daily AQI value for county, state, and also the latitude and longitude. Because as I said earlier, some counties have multiple sites. And so it's actually going to be more an issue of not so much trying to link zip code based upon which county it is in, but I believe probably the best method is to try to figure out where the zip code exists in relationship to the closest site based upon its latitude and longitude. So we'll get into exactly how we're going to calculate that, but for now what we're going to do is we're going to create basically this large parent data frame, which I call EPA.agg, and I'm going to do it for every file that I have in here, so all 50 states plus the District of Columbia, Puerto Rico, and the Virgin Islands. And what I have here is I get a total number of observations after I run this loop of 1,312 observations across 6 variables. And so we can look at this pretty quickly. You can see I get the site latitude and longitude, the daily AQI value, the PM25 value, the county that it's in, the state that it's in as well. But I only get 1,312 values, and as a quick kind of reminder, the total counties in the U.S. is actually 3,143. So we actually have fewer sites than we do counties. So that means that if you tried to just match things based off upon the county that somebody was in, you probably wouldn't be able to find a match for them simply trying to match based upon information here, because they might be outside of that county that has a site and therefore would not receive a match. This was kind of the first attempt that I made, and that actually didn't work out very well. I had a lot of missing values. And so what we're going to do is really try to find which of these sites is closest to our zip code, to the zip code that each individual has provided us. And so we've run this part of the code here. This part of the code is now we're going to pad a 0 to the front of all zip codes that only have 4 digits, which I kind of gone over before. And then we're going to get into exactly how we are going to, one, get the latitude and longitude of each participant zip code that is provided. And there's really 2 methods to do this. We can use the zip coder library, which uses census data to be able to take a zip code and then provide a output of actually a variety of information that is actually pretty useful. And so I'll show kind of an old one that I've already loaded here, which I called Z when I ran this loop. And what we get is the zip code that we put in, the major city, the county, the state, the latitude, the longitude, and also some interesting other census data here is the total population, the population density, very high given this in New York City, the total land area in square miles, housing units, the median home value, the median household income, and other types of information, just kind of the overall size, somewhat, or kind of the boundaries of this particular zip code that we can utilize to also kind of give ourselves some additional data as we're kind of working through this. So I'm also going to include the median household income into my data set, because maybe I'd like to be able to look at the relationship between household income and average air quality index and see if there's any relationship there. And so what I'm going to do is, so that's what Zipcoder can do. Zipcoder will provide you these things and you can index them fairly easily and then just kind of add them into your data set as you go through the total number of zip codes that you have from your participants. The other thing you can do is you can use ggmap, which is Google Cloud to be able to run a query and provide the longitude and latitude for the zip code through the Google Cloud. And I found that this one is a little bit more, it gives a little bit more data than perhaps if you just use Zipcoder. So, but it's a little bit more involved. So what you actually have to do if you are going to want to use geocode to be able to use Google Cloud to be able to get as much, I think the maximum number of feasible latitude and longitude for each participant zip code, geocode is the way to go, and you get that by loading the ggmap library. And what you have to do though is you do have to register and create a Google Cloud account so that you can get what's called an API key. And you're going to use this function here called register Google, where you're going to put in your key here that's provided to you after you register your account, to be able to then actually use geocode. If you don't have an API key, then geocode is not going to work, and that you have to enter this in every session. And you do not want to give people this key because it is linked to a credit card that Google requires you to use, so that and just in case you kind of run up any values. But using geocode in this context does not run up any charges, and you get a $200 credit just for registering. So you should be safe, and you can get alerts as well. So I'll kind of show you what it looks like actually. So here is my, I don't think I have my API key anywhere, but you can see here's the number of requests I've made through the geocoding API. I have not made any bills, even though I've run over 5,500 requests. And this is just what it looks like. You do this by going to the website here, and they'll ask you to get started. You just have to link a credit card to your account, and then you'll be given your API key, which you then input here. I would then, after you use it, if you're going to share your scripts, make sure that you do not also share the API key. Save the API key somewhere safe. So the way that this then works is I'm going to use a loop to get longitudinal and latitude data from both zip-coder and from geocode, and basically to be able to compare and contrast. So I have some kind of way of being able to check the overall validity of the kind of longitude and latitude data I am getting from these things. Even though they say they're going to do what they're going to do, it's not always wise to just kind of trust something that comes right out of the box. So I've already run this. This takes a little bit of time to do. Every time you pass geocode, the geocode command, it will go to it has to make a call to the to Google Cloud and then return the information. You can definitely slow this down. I've done the silly thing here, and I've called geocode twice to get the same information. I would probably, to make this a little bit faster, actually just put geocode on a separate line and then just save the longitude and latitude as a separate thing, and then store it into whatever variables I have into my database accordingly. So I'm getting the longitude and latitude from zipcoder as well as from geocode, and from zipcoder I am also getting the median household income. So what I've observed here is that with my data, and this might not be true for everybody, is that with the zipcoder, the total number of missing values that I have was 37 out of 1,397. And so total, that's only about 3%. But with geocode I only had 8. So that is a better number, obviously, but it's not like crazy difference. It's less than 1%. Okay, so if you want to be able to really maintain, if you want to try and leverage, I think, this ability to link zip code data with, or zip code information, the information you can get from a zip code, to air quality index, geocode is probably the better way to go, although we're really talking the difference of really 2%, between these two methods. But this can vary depending on the type of data that you have. And so I'm going to compare basically the latitude values that I got from zipcoder to the latitude values that I got from geocoder. And what I observed is that essentially they fall along a very nice straight line, but with some kind of differences here. And we'll kind of get into exactly how these differences can kind of create some very kind of funky results at the end of it, but all things that you can at least check, control for, and modify after the fact. But basically the data that you're getting from zipcoder is the same data that you're getting from geocoder, so keep that in mind as well when we're kind of working with these different types of packages and libraries. This was an attempt of something that I tried to do where I matched things based upon just the name. So if I had county in my zip code file and I had county in my county name in my AQI site data set, I could try and merge them simply based upon the spelling of those words, and I could do that kind of through this fuzzy logic using the it's called the I don't know if I have the fuzzy join library, which I haven't used anymore because I was kind of getting a lot of data that I wasn't getting as much data as I was hoping for. The joining function really did not work as best as I wanted it to. There are a lot of parameters that also go in here, like the distance method and the max distance method, that can be something that you are kind of free parameters in a way that you have to pick, and therefore how is the best way to validly pick either of these parameters, both the method and the max distance, became something of kind of randomly picking things and narrowing down what I thought was working best, and I wasn't being very systematic in doing that. So I skipped this method. I decided not to do it because I want to kind of show you here that what's interesting about air quality data, if you go to the EPA, they have this nice map, and here what I'm showing you is all of the air quality index sites that record PM 2.5 data from them. And as you can see, they're very much clustered around the populated areas, but they're also not like evenly distributed across the United States. They're obviously meant to be recording air quality where the most people are. We're trying to get the most coverage for the most people. But obviously not everybody is going to live in the closest proximity to any one of these air quality monitors or these sites. So we have to figure out if somebody does live here, say for example they live in California in a county, but the closest AQI is actually farther from them than perhaps a site that's actually in Nevada, then that is something that we need to be able to probably better account for, and that we might want to use the site that is closer to them actual distance wise versus the one that they would be assigned to county wise. And so that's where I came up with this idea that we probably need to be able to determine the minimum distance between the zip code and all of the available sites, of which there are 1,312, and just use the data from the closest site that they have. And that way we can get a close enough approximation, and we can then look at the overall distance that they are from that site to make a determination if that measure that we're getting from them is in fact valid, that we can then use that as a way of being able to get perhaps I think the best quantification of a person's air quality over just the amount of time that we have air quality data for based upon their zip code data. And so the way that I did this is that I take the participant zip code. So this is going to be a double loop. So in the first loop I'm going to be iterating through my zip code data from my participants, and the second loop I'm going to be entering the zip code data from my sites. I'm going to be labeling latitude 1, longitude 1, latitude 2, longitude 2, and I'm going to be determining the distance between these 2 points using the Haversine formula. And this is essentially finding the distance between 2 points that have longitude and latitude, so on a sphere. And so this is not using the Euclidean distance as if we were on a flat plane. This is to do this for if we're on a sphere. And so this will allow us to have, I believe, a better way of identifying kind of weird or more close type of sites to our participants using this type of metric compared to if we just went with simply the Euclidean distance. And so what this will output is all of the a vector of the distance in kilometers for every site for each participant. And so this will be for participant 1, this FI, for all 1,312 sites. When we then exit that loop, we are then going to find the index of which of the sites has the minimum distance. If it can't find something, as we said, we have at least 8 values when we're using the geocoder data that aren't going to return a minimum site because we do not have longitude and latitude data for those individuals, it's just going to skip it, and it will be basically inputted as an NA for the following variables that I'm trying to collect. So that's what this if is empty is doing. So if this is empty, there is no distance because there's no longitude or latitude, then we're just going to skip it and move on to the next iteration, to the next participant. And so what we're going to store is, with that minimum index, we're going to store what is the site distance for what is the closest site for that participant, and then what is the air quality data for that site, and what is the PM25 data for that site as well. And then I just print it to track. Running this actually runs a little bit faster than running this because, again, I probably shouldn't have used 2 geocode calls. But what we found was that when we then look at the number of missing values after this is running, I find that I have actually 0, which is interesting given that I know that I have at least 8 missing values. So there's something that we need to look at there. The overall histogram of site distance here, we see that we have some people who are one person is 8,000 kilometers away from the nearest site. So there's something weird happening there, but we can look at the data to basically try to figure out what the issue may be, and we can troubleshoot that. But overall, it looks like that's only happening a handful of times out of the over thousands of times that we've done this. And so the median site distance is 11 kilometers, the mean site distance is 56. And so that seems to be a fairly good distance proximity that each participant is to at least some site within the US that I was able to collect from this EPA data. And so if we really look at the data here, which is my zip, what I can see here, if I look at site distance, this individual who is over 8,000 kilometers away, their zip code is 54770. I can use geocode, and I can put it in here now as a way to troubleshoot, and that was 54770. And what I have is that this is not uniquely geocoded. So what it has done is instead has given me the longitude and latitude for Punjab, Pakistan. So that's why it's so far away. So what I need to do is basically go back and verify this. And what I can see here is that the longitude and latitude data that I got from Geocoder is different than that from what I got from the latitude and longitude from Zipcoder. And so we can see that if I now go into the site and I go zip code for longitude and latitude, this is someplace in Wisconsin. I can double check my data, and of course that's what they report, that they're in Wisconsin within this county. And the longitude and latitude were 44, 91, and that's what I have, 44, and 91. And so I would actually be getting a better value if I were to use Zipcoder here. That's actually accurate toward the actual location within the United States. But I would just be able to need to change this by hand perhaps in order to do that. And as I look across all of these, I have about probably a handful here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 zip codes that I think I would have to personally check to be able to make sure exactly what is going on here. And then the rest of these maybe I'd also have to check as well, but it doesn't seem too infeasible, in a place like Texas for someone to be 200 kilometers away. If we look at our air data here, perhaps this person is right in the middle of the state, and they're actually not able to, it's a pretty far distance from where they're able to get where a site is from them. Okay, so it doesn't seem totally unreasonable, but it's, again, something to verify. For the most part, though, I think where it's worked fairly well. And so as a quick way to kind of be able to now compare and start to ask actual research questions based upon just the data that we've gotten from these different packages within R and the EPA, is I can look at the relationship between the mean AQI of the year 2021, and then the median income as reported from the census that I collected from zip code, or so it's the median income of the zip code. And what I see here is actually this negative trend, whereas median income of zip code goes up, the mean AQI of 2021 goes down. And if I then run a quick analysis on this, I find it statistically significant. And overall, after doing a little bit of math, I was able to figure out that for every $34,878 that the median income of the zip code goes up, then the AQI will decrease by 1 point. So although this is statistically significant, there really is the kind of small relationship here between the kind of wealth of a zip code and the overall air quality of that zip code. But nevertheless, this is something that we are able to look at just from zip code data provided by participants. So that concludes the tutorial. I'm going to be posting the script as well as the data that I collected from the EPA for the AQI data. Open to any questions and comments, and I hope you found this useful. All right, see you at the next one. Bye.